Okay, rightio. So for our last one, we're going to have a look at a shape that's got a hole in it. And while you were away on the video, the class has constructed this awesome shape, which is kind of entertaining, and to say the least. So this piece is a hole, is the essence. So the shaded in piece is a hole, is what it is. Everything else is solid. We've got a circle with this weird shape punched out of it, is the essence. And we're going to try and figure out where the centroid of this thing should be, so the balance point. So my feeling is, if that's the middle of the circle, this side of the circle is now a bit lighter, so the balance point should come down this side somewhere. The balance point should be in this quadrant, somewhere in that space, roughly is where it should turn out to be. Okay, so let's go through our step-by-step process and see how far we get. Step 1, define an origin. Where do you want to put the origin for this thing? Top of the circle. Okay, I'm going to live with that because we don't really have a corner that we could do. We could put it. I'm getting a few shaking heads. What are you going to suggest? Good question. Does it have to be on the shape? Why does it have to be on the shape? Because you like it on the shape. Okay, so what are you suggesting, Emery? Rather than being on the shape, you're suggesting doing something like this? And putting the origin out there? Yeah? And then everything is left and everything is down. Yep, or as I say, everything is awesome. Okay, so everything is left and everything is down. Okay, because yeah, we're part of a team, etc. Yeah, it's all good. Yeah. Okay, so everything is left and everything is down, and we're ready to go. Okay, so 3 shapes. What 3 shapes do we want here? The obvious first shape is the circle. Okay, so let's call the circle shape A. We can do a circle for shape A. Okay, what do you want to do for shape? Remember, I had to use squares, rectangles, triangles, circles. So what do you want to do for the next shape? Let's rub this stuff out so we can draw some lines if we need to. A right angle triangle in the real weird shape. So that one and that one. Okay? Yeah, that looks reasonable. So B and C are now both holes, but they're shapes. So that fully defines the shape, doesn't it? So A is the circle, and then out of the circle we've removed a triangle and a rectangle. Okay? I don't mind that. Let's rub off some of these numbers while you have a think about trying to work out the next ones. So again, my table from last time I can just use. It's exactly the same process. Again, coincidentally, I've only got 3 shapes to worry about. So we're all good. Okay, so we all got the calculators going and working out what's happening here. Oops, should have rubbed that one out, that could have stayed. Let's put that one back up again. Oh, good question. Have we not defined our shape well enough? How far from the side, and how far down, I guess, as well, is the funny shape? Great question. Let's do it from the middle of the circle, shall we? So if we do measurements from the middle of the circle, then we're going to call this one 100 across to there, and this one, a bit less than it, 80? 80 it is. And this one's 70? All right, good point. We did need those numbers. How far, where is it? Good thinking. Okay. It's great we just make up numbers. We'll make up this one. If you're in an exam and you get to that position where you're going, this is missing, make it up and write a note to the examiner. Dear examiner, I think you're a plonker. You needed to put this number on. Try not to be too abusive, just in case it wasn't necessary. But if you do, just make something up and go, I'm going to put this number in here and assume this is the case. Okay, so area A, how big is that circle? Has someone worked out the size of that circle for us? Shane's not looking confident. pi d squared over 4 again will do it for you. Okay, I'm getting the same sound from two, getting an echo here, so 2, Alex, 2, 6. I'll call it 2, 3. Is that the same I heard from the other side of the room? Someone was getting the same noise? Yep, happy with that? Okay, so we've got an area for the circle. Okay, what about the triangle? The triangle is 50 across here by 100, so that's 5,000, so half of that is 2,500. Up, that was a B, I did right, yep. And then that is 5,000. Okay, and here's the important bit. When you're doing shapes with holes, the holes count as negative area. Okay, so that's really the only difference. If you make the whole shape negative, the maths will look after everything else. Because when you add up the area, you want to do the big circle, take away the other two. So you can still just add them, and the negative will look after it, and you'll come up with a good answer. So if we do that, what do we got? Hang on, I was wondering about the total area here. 262203. Okay, so that's the total area. Happy with that? Brilliant. Deep breath. Get ready to go for the X's and the Y's. Okay, so we're going from the point which is off the side. Thank you, camera operator, for your suggestion. Okay, so we're going from here across to the left. So to get to the middle of the circle, how far are we going? 293. If the units aren't given, whatever the units are, the answer will be in the same units. So with numbers like that, I'm assuming millimeters, but maybe it's something really big, it's in meters. And you're trying to blot out half a city or something. Yeah. No, let's assume millimeters, but we don't know, we're not told. Maybe it's micrometers, maybe you're making some tiny little parts or something. Okay, so 293 is just half of the 586. That's where that came from. Okay, what about the rectangle, sorry, the triangle? How far across do we have to get to the middle of to get to the right point on that? You guys pick great numbers here. This is a genius effort. 1 second. 3. Okay, so how'd you do that, Shane? What you thinking? A guesstimation. Okay, okay. So this is a Shane guesstimation. I'm sorry, Shane. This is my confidence levels. Okay, it's not a guesstimate then. It's actually good. Yeah. 293 to the centre. Yep. 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 I really like that. So you're saying 293 to come across to here, and then you've gone back 80 for that bit, and then you've gone back 50 for that bit, and then you've gone back 1/3 of the triangle, which is 1/3 of 50. And you reckon that might be 171.3. 146.3. This lot's 130, so that'll be 163. Yeah, 171 does seem a bit big. Just straight away, if you take 80 off, you get 213. Take 50 off, you get 163. That's 16.666. So what did you come up with? Carry that soon. 146.3. Idea was awesome, Shane. Execution sucked. Yeah. Anybody else get the same 146.3? Oh, yeah. The problem was it was a guesstimation done with a calculator. But the process was great. The idea was brilliant. It's just something died in the button pushing. Yep. So we're happy with 146.3? Brilliant. Okay, so that doesn't equal 173, it was 146. But great idea. I don't know what happened, Shane. I like what you did. Okay, so C, to get to the middle of C, what are we going to do to get to the middle of C? Same thing, so 293, take away 80, take away how much? 293, take away 80, take away 25. So 293, take away 80, take away 25, which is 105. So it's going to be 188. Yep. Good thinking. That works. But it's that sort of process you need to go through. It's just imagine this line moving across the thing. How far? Always back to the start. How far do I have to go to get to certain places? It's really, really good thinking. Okay, so let's have a worry about Y. So to the start, how far down do I have to come to get to the middle of the circle? Again, it's halfway through the circle, so that'll be that same 293 again. How are we going to do the triangle for this one? Okay, so come down 293, back up 70, and then back up a third of 100. Yep, and that comes to, what'd you get? You haven't done it. Someone's done it? $189.7. Yep, someone else says yep, sounds promising. Alex is nodding, it was his idea, so we'll stick with that. And then the last one is going to be down your 293, back up 70, and then back up 50, which is 173. Okay, so that's really all the hard work done. We've done all the thinking about what's doing. The rest is just multiplication, a bit of addition, a bit of division, and we're there. So it's the hard work is figuring out where the bits of the various shapes are. Okay, so who's pushed some buttons and can give me some numbers? Where? This one? Okay. Is this up? Is this one down? Yep. Negative. Where? Anybody got any other boxes to fill in? This one? Negative 47. Right, okay. 3 boxes to go. Total for X, yep. All right. 9 at the end. Yep, CY. Brilliant. Okay, one more summation and a couple of divisions and we're there. Seven, 7, 6, 8, 3, 7, 2, 9. Let me write that number down. Divided by the total area. Okay, X and Y, what do we got? 296.3. And Y is... That was the Y. Slight drama there. Somewhat of answer for X. this one, x, 296.4. Yeah, so basically what we're saying is it's about here somewhere. Yeah, a wee bit more maybe, but not much. Yeah, and they're fairly similar. Yeah, because we've got this thing offset pretty evenly, sort of 80 in centre, so it's pretty much off at an even offset, so the answer should come at an even offset on this side. The fact that that's such a small distance off is because the circle is really big compared to the hole. Yeah, so the hole's not going to weigh it much off the centre. And it's also relatively close to the centre. If we do this thing to scale, from here to here is 293, and that's only 80, so it's not bad. It's not too bad, not too far off scale, but it's the circle is dominating. You can tell that straight away by looking at the size of these numbers compared to these numbers. The circle is providing most of the answer. Okay, so the key thing here is when you're doing things with holes in them, the areas that are associated with the holes have to be negative. And then when you carry the math through, you get a negative over here, because a negative times a positive is negative. Same here, negative. Add them up with negatives in, do your division, and everything comes out in the wash. So the negatives look after everything. So the maths will do it for you once you have those initial negatives in.